In this lesson, I'll be covering the mean and standard deviation and what these terms are, how we calculate them, and how they relate to collecting data in the lab. Now, you've probably heard of mean, and that's just the average of a group of numbers, and the standard deviation shows the variability or how different or how repeatable numbers are in for example, this instance, the lab. So if we're collecting information. Now we're going to just start with a sample here of if we were in the lab collecting masses of, say, we can have anything, silica sand. We're collecting a mass of silica sand, and we're going to collect 5. So here we have 5 data points. We're going to collect the mass of the very same sample 5 different times. And the first time we collect, we put on the scale, we end up with 10 grams, and we have 9 grams the second time, 8 grams the third time, 11 grams the fourth, and 10 grams on the 5th time. So each of these is x sub I, or x sub 1 is the first, is sample number 1. Sample number 2 is x sub 2. In other words, we're just taking the sample and putting it on the scale, weighing it, and then coming up with the mass here and making a table from this. Now we've collected 5 different data points in the lab and masses for each of those. So first, let's start off by calculating the mean, or the average of these. I've written the equation here for the mean, and this may look confusing, this terminology, but what it really is showing us here is that we're just adding up. You know how to do the average, which is adding up each of these numbers and then dividing by the total number. That's what this terminology actually is indicating. It's telling us to add up each one of the x sub I equals 1. So that's indicating add up each, that's xi is 1, so this is the first data point, and it's telling you to add up from the 1 to the total number of samples, and n is the total number of samples. Here, n is 5 because we have 5 samples, and then we're just dividing it by n. So that looks like the average that you probably know how to do, which is 10 plus 9 plus 8 plus 11 plus 10, and we're dividing all of that by the number of samples n, and then we come up with in our if we calculate this out, our average or our mean of the samples is 9.6 grams. So I wrote the mean down here because we'll be using that number again in the calculation for the standard deviation. The next part of this is to look at the standard deviation, or in other words, what is the variability in the samples that we measured. So here I've written the equation for standard deviation for you. I moved the equation for the mean over here, and I've written the equation for standard deviation here. It looks super confusing, but it's actually not. It's a lot of terminology that really just means, as in the mean, that we're going to add up all the values for each of the sample points, 1, and in our case, n, the number of samples is 5. We took 5 samples, so we're just going to add this calculation up for each of our sample points. Now, x of I is indicating which of these we're on, if it's 1, 2, 3, 4, 5, and then minus the mean. Now, here's a good point, is that if we have a number lower than the mean, for example, the mean is 9.6, when we get to our second data point, it's going to be negative, and so this is where the square comes in. Because we couldn't add up a bunch of positives and negatives, we just end up with 0, and there'd be nothing to divide to take the square root of it and there'd be no standard deviation. So it's square, but then the square root needs to be taken. So let's just go over the example of the first one really quick as we calculate this out. So we're looking for standard deviation, and we're going to first add up all of these calculations. And the first one here is x sub I, or in other words, take the first sample, which is 10 grams, minus the average or the mean, 9.6 grams, and square that number. Then this summation sign means we just move right on to the next sample point. 9 minus 9.6 squared. And on to the next sample point, the third one. So we're now on x sub I, or x sub 3, which is sample point number 3. And we have to take 8 minus 9.6 and square that. So here I just went ahead and wrote out the calculation for the standard deviation of these values. And 10 is the first data point, our 10 grams, the mass, minus the mean, which was 9.6. That's exactly what this means up here. Just x sub I is x of that data point, 1 through 5, minus the mean, and you square all of it, just in case, as in the second sample point where we have 9 minus 9.6 would be a negative 6. So we square that, and that makes it a positive, and we can add all these up. And then we divide by n, or the number of samples that we have, or we took. So we had 5 samples or data points, minus 1, which is 4. And then we divide the whole thing. We take the square root of the whole thing, and we end up with a standard deviation. If you just plug that into your calculator, it comes out as 1.14. And this is describing the variability, or the difference in each of these sample points. So I went ahead and wrote our standard deviation of 1.14 over here so we can see that. But then we need to know, what does this mean? And we can start looking at how we use standard deviation on a graph. And I'm going to try to write a very smooth line here. The bell curve should be, of course, exactly equal on both sides. And we're looking at standard deviation. The center of the bell curve describing our data, or information that we collected, is 0. And then as we go out in each direction, we have 1 standard deviation away from the mean, is the first data point. And we see, if we're looking at the bell curve graph, 68.2% of all the data points that we have collected should lie within plus or minus 1 standard deviation. That means that everything that we collected and would collect after this should lie, if this is statistically significant, we should be able to find all 68.2% of all of the data points within plus or minus 1 standard deviation of the mean. So all of those data points should lie within plus or minus 9.6 grams plus or minus 1.14 grams. And we'll find that most of our data, it is true, lies within that range. Now, if we look out farther to 2 standard deviations, 95% of then it just captures more and more of the information. 95% of our data points will fall within 2 standard deviations. So you see, the basket that we're capturing data points is just getting larger and larger as we go out from the standard deviation. Now, within 3 standard deviations, almost all of the values will fall, because then at 3 we get to 99.7%. So by the time we've got out to the third standard deviation, plus or minus the third standard deviation, we should have basically capturing all of the values, almost all the values, 99.7% of the values that we have collected in the lab. And if this is statistically significant, that should happen over and over and over once we've calculated the mean. So the last point here, we calculated everything out by hand, and hopefully you understand a little bit about what it means to use the mean and the standard deviation to show variability of sample points or data points that are collected in the lab. Frequently when we collect information in the lab, we'll use, you guys might be using Google Sheets. You might write it down in your lab book and then go and enter everything, all the data into a spreadsheet. And you could use Microsoft or Apple products, or I'm just showing you here, for example, Google Sheets. And so I've created a data table, and I've entered the sample numbers as we had before when I was writing them down, and the sample mass of each of those times, or sample numbers. So the sample number, again, we use the notation I for sample point 1 or 2, 3, 4, 5, and the sample, and then the actual value itself we used as X. So this is the sample 1. We measured in 10 grams. And actually, I'm going to add this because we should always have units. There should always be units in our tables and calculations. We want to keep track of units. Now, just the way, if you can use it by the calculator, which we did earlier, but the other way in a spreadsheet is to just enter the information in a table and then use the information. So here we Google Sheets uses the word average to mean mean, and then we just highlight all of the data points that we have, and we come up with the average. And then also we can do the same for standard deviation here. And then from that, you can actually, the spreadsheet itself, you could use the spreadsheet to calculate all kinds of specific statistical analysis on data, or you can just take those, now that you have those numbers, and make your own meaningful bell curve and describe the variability of the samples that you collected in the lab. So numbers that, if they increase, the increase in standard deviation is more variability, which could be introduced from the equipment you're using or the different lab partners and the way your methodology, different things like that you would be introducing variability. And then lower number on the standard deviation is a tighter bell curve or less variability between your sample points in the lab. So this is actually how we can use a table for presenting our data from the lab, and use the spreadsheet itself to do the calculations and then understand what this means that way. So I've gone over the equations for the mean and standard deviation and told you what that all means. They were really crazy looking equations, but they actually are not that confusing when you figure out what all of that notation means. And then here we just add everything into a spreadsheet for our lab report.